machines. I think a gentleman is already confused about there are so many chips, but I'm going to give you more. Okay. This is the Sahara. I think you may use this before. Right now we provide the Sahara 2 solution. And this is quite small form factor, and the capacity can up to 128 GB MLC and 64 GB for SLC solution. And also we built in the pin 7 VCC. As you know, the SATA connector is a 4-pin for the data and then 3-pin for the grounding. This is standard. But you know, for the embedded system, there's a power cable is not quite good enough for the embedded system. So that's why we choose the one ground pin for the VCC to provide the power for the SATA. So if the motherboard design, you can implement the VCC for the pin 7 power, and then you don't need to have another power cable. Okay, actually, even just SATA, we have more than 10 choices, the different form factor. Have a bigger one, small one, and right angle, and then without housing, with housing, and also have horizontal and vertical. This is why we design so many different solutions, because the embedded system is quite small space, so there are some have mechanical issues. So we design so many solutions. It depends on the customer requirement. Okay, right now we are developing the SATA 3, SATA 3.0 GHz solution. So we can actually this design can support 19 and 20 millimeter MLC, but according to our experience, when the new process going to the market, we almost every time we need to spend around 6 months to fine-tune the firmware to support the new fresh MLC technology. And we also support toggle and AMPI interface, toggle and DDI interface. And also the low power mode design, we can support slumber and then device sleep mode also. And as I just mentioned, for the SoC can up to 64 gigabit, and MLC can up to 128 gigabyte. Sorry. And there's an example for the performance. Right now is the prototype. The read can up to 400 megabyte, and write is a 200 megabyte speed. And the size is quite small. It's like this small size on my hand. Okay. So we InnoDisk developed the small form factor in SSD is almost 7 years. So we are trying to design a bigger capacity in a very small form factor. And this is another one we call the USB OS drive is 3.0. So as I remember, almost like 10 years ago, at that moment we developed the USB 2.0, and at that moment we cooperated with some embedded IPC design house, and we spent a lot of time to overcome the OS boot drive problem with the Windows embedded system. And finally, I think because the PARA interface and SATA interface is quite popular, so that's why the USB 2.0 cannot show success in the embedded system. But nowadays, Windows 8 already can support OS drive boot, and also the Linux also can support the boot from the USB. So we think in the near future, maybe USB 3.0 is another choice for the embedded system. So you can see even the size is smaller than our SATA. It's very small. And then compared to the SIM card, it's maybe just half size. Okay. So this solution also can support 19 and 20 nanometer MLC because we embedded 43 bits ECC per K. And so right now we can provide up to 64 gigabyte solution, and right now it's a 2-channel, and speed is up to 200 megabyte and write 90 megabyte per second. So compared to USB 2.0, USB 2.0 only 60 megabyte per second is a limitation, but USB 3.0 is almost 600 megabyte per second. But right now our design just 2 channels, so that's why we only can provide a 200 megabyte per second speed. But if compared to USB 2.0, almost is already 10 times faster. And also, we already tested with the Windows 8, and then OS booting time is less than 20 seconds. It's almost the same as the SATA SD drive. So I think in the near future, maybe USB 3.0 is another choice for the embedded system. Okay, and this is I think you should the first time hear about the CF SATA solution. 10 years ago, I remember when I'm beginning to design the fresh product, I designed a 16 megabytes pen drive and then also the CF card. So the CF card in the embedded market over 10 years is quite popular in this market because the socket is very reliable and there is no any vibration shock issue, and also because the camera used a lot of CF card before. So the design cost is very low because the connector is quite popular, and so the connector used CF standard connector is quite cheap. So we also provide a C-fast solution to the embedded market, but we are thinking about can we use the same connector, CF standard connector, to run the SATA signal. So we study the 15 pin with the CF connector, and we find the true IDE mode is on. There are so many reserved pins, and we pick up 4 pins for the data. And this data pin in the true IDE mode is the ground pin, but in the memory mode or I/O mode, actually it's the address pin. So but we work with the embedded IPC design house so close, so we talk to them about the memory mode and I/O mode. Actually, in the embedded system, there is nobody use the I/O mode and memory mode, so they only use the true IDE mode. So that means after we discuss with the motherboard IPC design house, they think we can implement in the motherboard, we can have the PATA CF card signal and also have the SATA signal. That means once you design this motherboard, you can use the CF card now. But in near future, if you think you need higher speed, and then you can choose the CF SATA. So the CF SATA is very simple. It's the standard CF connector, and we only use the 4 pin for the SATA signal. So in the host design, and then you can use the CF card, and also the same motherboard, the same connector, you can use also CF SATA design. Okay, so actually we pick up the pin 10, 11, and 15, and 16 for the SATA signal. And there's a issue about is the pin header is okay for the SATA signal. Actually, right now we provide the SATA 1 solution is 1.5 G to the market, and then I think the SATA 2 is also no problem. And then we are working on the SATA 3 solution to overcome the signal issue. So I think this is another option for the embedded system. So you can have the PATA interface and then have the SATA interface. So in this kind of the small form factor, is almost similar compared to CF card and CFast and CF SATA. I think the CF card in the embedded, I think still have years. The embedded system still use it, but in the future, because the chipset already, the old chipset already phased out, so the new chipset only support the SATA interface. So the SATA will become, in this kind of form factor, will become the major interface. So CFast, why, maybe the people will ask us, why we just don't use the CFast? The CFast right now have the issue is it's not so popular in the camera yet, so the connector fee is still high. So maybe if you can design, use the same form factor, same connector to design with the PATA and then also SATA signal, so you can get both advantage. So maybe CF card still very cheap on the market. Okay, thank you. We have a booth here, so you can come over to our booth. We have live demo here, there. So thank you.